Welcome to Gooseberry Science and Educational Videos. We celebrate a lot of science days throughout the year, but some just feel different, bigger. On April 14th, 2026, the world didn't just celebrate quantum science, it felt like we got a real look into the future. Two huge announcements dropped that day, and they suggest that future is getting here a whole lot faster than we thought. So, on this one day, we got news that could literally reshape everything, from medicine to national security. And it all centers on this number, 4.14. So, what's so special about it? Why does it get its own day? Okay, so before we unpack all that groundbreaking news, let's just talk about the day itself. We need to get into the what and the why behind this worldwide celebration of all things quantum. First things first, why April 14th? I mean, is it just some random date? Nope. It's actually kind of a brilliant little inside joke for physicists, hidden right there in the calendar. It all boils down to this really fundamental number called Planck's constant. Think of it as part of the rulebook for the truly bizarre world of quantum physics. And if you take its value and just round off the first few digits, what do you get? Yep, 4.14. So April 14th. It's this great little nod to one of the universe's most important numbers. And honestly, that clever little date really captures the whole point of the day. It's a grassroots effort all around the world to pull back the curtain on quantum science for everybody. The goal is to show how it helps us understand the world around us, how it's already powering technology we use every day, and, this is the big one, how it's about to kick off a whole new technological revolution. But this year, wow, it wasn't just about celebrating. It came with some actual, honest-to-goodness headline news. Two of the biggest names in the quantum space dropped major announcements that show real, concrete progress. So on one hand, you've got IonQ, a leader in quantum hardware, announcing they've actually connected two of their machines. And on the other hand, you have the AI and chip giant NVIDIA releasing a powerful new tool to make quantum computers smarter. So think of it like this. One company is focused on connecting the machines, and the other is focused on correcting them. And trust me, both are absolutely massive steps forward. So connecting and correcting, what does that really mean for the future of, well, everything? Okay, this is where it gets super interesting. Let's get into it. All right, let's kick things off with IonQ. Their CEO, Niccolo de Masi, he called this a pivotal moment. And believe me, that is not an exaggeration. What they're doing is moving beyond these single, isolated quantum computers and starting to build the foundation for a quantum internet. But what's so cool is how they actually pulled this off. They used particles of light, photons, as little quantum messengers. So they generated a photon from a quantum bit, a qubit, in one computer, zipped it over to a second computer, and then used it to entangle the qubits in both machines. You know entanglement? That super weird quantum connection where two particles get linked and perfectly mirror each other no matter how far apart they are. What you end up with is a totally secure quantum link between two different computers. That's a foundation for a quantum internet right there. Okay, so now let's hop over to NVIDIA. While IonQ is busy connecting machines, NVIDIA is attacking an equally important problem, the fact that quantum computers are incredibly fragile and, they make a ton of mistakes. As their CEO, Jensen Huang, says, they're basically using AI to create the operating system for these powerful but delicate machines. And to really get why this is such a big deal, you kind of have to understand qubits. See, a normal computer bit is simple. It's either a 1 or a 0, on or off. A qubit, though, it can be a 1, a 0, or both at the same time. It's not an on-off switch. It's more like a dimmer switch that can be at any position in between. That's what makes quantum computers so powerful. But it's also what makes them so unstable and error-prone. And that's exactly where NVIDIA's new AI model, which they're calling Ising, steps in. It's built to do one thing, find and fix those errors. And I mean, check out these numbers. Compared to the old way of doing things, it's up to 2.5 times faster and, get this, 3 times more accurate at cleaning up the mess these fragile qubits make. This is a game changer for making these systems actually reliable and useful. So what's the big takeaway here? The crucial point is that we're blowing past the theoretical stage. We're moving from lab experiments to practical applications. And that has huge implications. So what does this actually mean for all of us? Well, the promise is it's just huge. We're talking about the power to solve problems that are basically impossible for even the biggest supercomputers we have today. This could completely change medicine by letting us design new drugs molecule by molecule. It could transform finance, create new materials we can't even dream of, and even build unhackable communication networks.
But, and this is a big but, with all that incredible promise comes some pretty serious risk. The very same power that can design new medicines could also shatter the encryption that protects our entire digital lives, your bank account, government secrets, everything. Experts are already talking about a harvest now, decrypt later scenario. It's this really scary idea that hackers are just scooping up all our encrypted data right now and just sitting on it, waiting. Because they know that in a few years, they'll have a quantum computer that can crack it wide open.
So the news we got from IonQ and NVIDIA on World Quantum Day, it wasn't just some lab update. No, it was a signal, a really loud and clear signal that this quantum future isn't some far-off dream anymore. It's happening, and it's happening fast, which leaves all of us with one very big question. The quantum age is dawning. Are we ready for it?